Okay, now this is the second part for the chemical formulas. Okay, we previously have determined, in terms of the ions, okay, you need to remember them and you can find them generally on page 94 of your textbook. Now, subsequently, okay, not everything will be in ion form. What you'll be given is compounds like this or substances like this. You need to be able to determine the chemical formulas of them. So a simple rule, okay, or a simple sequence that you can think about would be this. First thing, check if they are elements. Okay, so elements are things that you can find in a periodic table and just as it's on its own. Okay, and then whether is it let's say if it's not an element already, then you can move on to check whether it's a compound. Now, what do I mean by check whether it's elements then compound? So let me go through a little bit with you. So let's identify first. Okay, in this whole sequence here, are there anything that's element? So oxygen is an element. Okay, oxygen is an element. So once I've identified as an element, I'll need to determine if it's going to be diatomic or just a chemical symbol alone. So how do I know whether it's going to be diatomic or chemical symbol alone? So for it to be diatomic, okay, do remember this group of elements called the H7. What are H7? Okay, in your periodic table, you can actually highlight them. It's actually hydrogen with nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine. Okay, these are the H7 elements. So if you ever see these elements on their own, okay, they will generally exist as a diatomic molecule. So for oxygen is an element, it is part of H7. Therefore, the formula for oxygen will actually be O2. Another element is nitrogen over here. It is part of H7. Okay, so these two are part of H7. So this will be N2. For fluorine, is an element. So a part of H7, fluorine is over here. So it is F2. Hydrogen is an element. It is part of H7, so it's H2. Okay. Now, what are examples of elements which are not H7? Okay, so I don't have one over here, so I'm just going to create it on the spot. So example, zinc or magnesium or maybe helium. Now, all these are elements that you can find in the periodic table. So they are elements. Are they part of H7? Zinc, magnesium, and helium are not part of the H7 elements. As such, the formula for zinc is just Zn. Okay, the zinc metal itself is just Zn. Magnesium will be Mg, and helium will be He. Then some of you must ask, isn't Zn 2 plus, magnesium 2 plus? Now, if you go back to the previous worksheet that we have done, you realize the header is the formula of the ion. Element itself has lost or gained electrons, whereas this one here we are referring to the element itself before it has lost or gained electron. As such, it is just the chemical symbol alone. Okay, so that is to determine the chemical symbol for elements. Now, with regard to compounds, how do I know what are the formulas of the compounds? So for compounds, you realize I did highlight that, for compounds, it's either you remember them through memory or you do this called the crossover method. Now, what are elements that you need to remember by memory? Okay, so example will be ammonia, methane. So M stands for you need to remember them by memory. Water. Okay, so these three, ammonia, methane, and water, you need to remember them by memory. So ammonia is NH3. You will come across ammonia quite frequent. Methane is CH4. Once again, this is another one that you'll see very frequently. And the last one is water, H2O. I think no problem for water because most of you already know its chemical formula. Okay? So, for some of them, I realized I missed out one part for compounds. Some of it is actually you need to use the prefix to determine the chemical formula. So let's look at the prefix types. So memory one, I've gone through ammonia, methane, and water. Okay, with regard to the prefix type. Okay, so there are, so example, carbon dioxide. So carbon means there's a carbon. Oxide means there's an oxygen. So because it is dioxide, di means two. So carbon dioxide means that this is a compound with carbon and two oxygen. Now, some of you are saying, carbon got no prefix. So there's nothing in front of it. How do I know whether it is 1, 2, 3, or 4, or how many? So do take note, if there's no prefix in front of the element, we will just assume that it is 1. Next one, carbon monoxide. So oxide again, carbon. So there's carbon, there's oxygen. No prefix for carbon, so just assume there's one carbon only. Monoxide tells you that there's only one oxygen. So for this formula, it is just carb CO. How about silicon dioxide? For silicon dioxide, I know there's silicon, there's oxygen because of oxide, and because of the word di over here, so I know there's two oxygen. For silicon, there's only one because there's no prefix over there. So this is silicon dioxide. Now, so I've gone through the memory type, I've gone through the prefix type. Okay, now for K, L, and M, okay, now I'm gonna start off with this tree here. Now this tree, I will say you can either choose to do it like a memory type, or you can choose to do what we call the crossover type. Okay, but let's start with the memory type first. So this is actually H2SO4. Just remember this for now. Nitric acid is HNO3. Hydrochloric acid is HCl. Okay, we'll come back to this later. But let's do some simpler ones first. Let's start off with maybe potassium iodide. I'm going to show you how to do what I call the crossover method. So I'm going to take S, potassium iodide. Okay, so potassium iodide is made of potassium and iodide. Iodide actually is iodine in the ionic form. So potassium is K, iodine is I. Now, potassium, the valency, if you were to look in the periodic table, is actually 1. Iodine, the valency is actually 1. You realize I'm writing this without the charges. Okay, because valency, I do not need to write the charges at all. And most of you, if you write the charges there, you will get very confused. Okay, and some of you will forget to remove the charge at the end of the day. As such, typically I only write the valency number, excluding all the plus and minuses. So potassium, valency is 1. Iodine, the valency is also 1. Now do take note, I'm writing it at the top right hand corner of each of the element. To do the crossover, you will take it from one element's top right, cross it over to the bottom right of the other element. So I cross over to K bottom right, K top right, cross over to I bottom right. So what I'm going to get is actually K1, I1. Now, in chemistry, when there's a 1 over there, we will typically just ignore it and we will write the 1 over there. So my final formula is actually just Ki. Okay, I'm just going to go for another simpler one. Okay, I'm going to look at silver chloride. So silver is Ag, chlorine is Cl. Silver, the valency is 1. Chlorine, valency is also 1. So if you do your crossover method again, you're going to get Ag1, Cl1. But once again, in chemistry, we do not write the 1 over there. So it's AgCl. So that's the formula for silver chloride. Now, these are the only two, okay, which are, these are the only two which doesn't involve any complex ions within this worksheet. So I'm going to go on to the previous worksheet, to another worksheet to just have a little bit more examples. So let's look at this one over here. Okay, I'm going to pick another one, magnesium oxide. So for magnesium oxide, okay, I got magnesium, so it's Mg. I got oxide, so it's oxygen, so it's O. Magnesium valency is 2. Oxygen valency is 2. So at this stage, you can see here, 2 and 2. So I'll cross over from the top right, go to the bottom right of the other element, top right to the bottom right of the element. What I'm going to get is Mg2O2. Now, another rule, so other than removing 1, the other rule that you need to remember is that I must always keep it to the lowest ratio. So Mg2O2 means that there's two magnesium, 2 oxygen. This is not the lowest ratio. I actually go down to 1:1. As such, this can become Mg1O1. And by applying the 1 rule, okay, making sure that there's no number 1 in there, so my final formula is actually just MgO. Okay, MgO over here. Now let's look at another one. Maybe let's try aluminium chloride. Right, aluminium chloride over here. Aluminium and chlorine. Aluminium valency is 3, chlorine valency is 1. So if I were to do the crisscross method, okay, the crossover method, what I'm going to get is Al1Cl3. So by removing the 1 over here, because we don't write 1 in chemistry for this kind of things, so what I'm going to get for my final formula is AlCl3. Okay, so this is with regards to getting the chemical formulas without, okay, I say again, without involving the complex ions yet. Okay, so this will be simpler for now. Now we're going to go on to the final part of getting chemical formulas with complex ions using the crossover method. Okay, so let's familiarize ourselves with the complex ions first. So as mentioned, for the positive charge, we have NH4 plus. So this is actually saying that I have NH4, 1 nitrogen, 4 hydrogen clustered together. If it's a plus, the valency would be 1. Okay, I'm going to write out the rest. So I got hydroxide minus. So what this means is actually OH with the valency of, with the valency of 1. Okay. Next one, I got NO3 minus. So NO3, 1 nitrogen, 3 oxygen clustered together minus. So this is actually NO3 clustered together, valency is 1. So plus is 1, minus is 1 because it's 1 plus, 1 minus. Now, what are the other ones that I must remember? Okay, so let's go on to all this. There's hydrogen carbonate also. So let's write it down. Hydrogen carbonate, HCO3 minus tells me that it is HCO3, the whole thing clustered together. Valency would be 1. Okay, these are all the single charge. How about the more difficult ones? We have the double charge. So SO4, 2 minus, actually is, let me do this again. SO4, the whole thing clustered together. Overall charge is 2 minus. This is the same as SO4. Clustered together, valency is 2. Okay. I also have carbonate, CO3, clustered together, 2 minus. So this would actually means it's CO3, the whole thing clustered together with a valency of 2. And another last one, phosphate, PO4. 3 minus represents 1 phosphorus, 4 oxygen clustered together with valency 3. Okay, so these are the complex ions that you need to remember. And let's try it out now. Okay, let's try to use and apply some of this. So I'm just going to go through 3 examples. Okay, 3 examples to just let everyone get the hang of it. So let's try the first one, silver nitrate. So silver nitrate, I got Ag, valency 1. Nitrate, okay, nitrate, as I mentioned, is a cluster of NO3. Valency is 1. So I cross over. Now, what I'm going to get is Ag1. And because NO3 is a cluster on its own, so I'll tend to put a bracket to remind myself that this whole thing is together. I can't change it. It cannot become NO2, NO, or NO4, no such thing. So NO3 means nitrate. How many nitrates do I have? Because of the crossover, I know it's 1. Now, as mentioned in chemistry that we don't have the 1s over in chemical formulas. So I got Ag1, NO3, 1. Simplifying it, I'll get Ag, open bracket, NO3, like this. Now, if outside the bracket there's no number over there, we can safely remove the brackets. So what we're going to get is Ag, NO3. This would be the final answer. Let's try another one. Okay, maybe I'll try zinc nitrate. Okay, zinc nitrate over here. So zinc is Zn, valency is 2. Nitrate is NO3. It's a cluster like this, valency is 1. So I do the crossover method. What I'm going to get is Zn1, NO3, whole thing is bracketed, 2. So Zn is 1, so obviously I'll remove the 1 over here. The bracket here, I got 2, okay, because the 2 here is not 1, right, so I will not remove. So my final formula is actually Zn, bracket, NO3, 2. So as long as outside the bracket there's a number larger than 2, we will let the bracket remain. Okay, let's try another one that's a little bit more complex. Maybe let's try ammonium hydroxide. 2 complex ions involved here. So what I'm going to get is NH4. Okay, whole thing clustered together. 1. Hydroxide, OH, everything clustered together. 1. Crossover. What I'm going to get is NH4, because it is a complex ion, so I'll need a bracket. 1 outside. OH, because it's a complex ion, so I'll have the bracket, the 1 outside over here. So the crossover. And what I'm going to get, because I know it's 1, so I'll remove the 1. So it's NH4, OH, with the brackets there. And as I mentioned, if there's a no number outside the bracket, so I will remove the bracket, and what I'm going to get is NH4, OH. So this is the chemical formula of ammonium hydroxide. Okay, so I've done a few examples over here. You can carry on with doing the rest. Okay, you can pause the video to look at all these examples, and you can try them out. Okay, I will not be going through them. Okay, that's it for chemical formulas. Okay, you should become really good at this because chemical formulas is a very foundational topic in chemistry, and you need to know how to get them. Otherwise, you are unable to get chemical equations, you're unable to be able to do ionic equations, and etc. Okay, so that's for chemical formulas. So just a quick summary that we have done. To get chemical formulas, first always identify whether they are elements. If they are elements, check whether they're H7. If they're H7, I'll take it as they are going to be diatomic. If they are not H7 elements, then we will just write the chemical symbol alone as mentioned over here, like zinc, magnesium, and helium, Zn, Mg, and He. Now, if they are compounds, means 2 or more different elements chemically combined together, first thing, we need to try to get some of them from our memories off. Example will be methane, methane, ammonia, and water. Possibly even looking at sulfuric acid, nitric acid, and hydrochloric acid. Okay, if they are not from our memories, okay, you see that it's not something that I will have remembered. We can try the prefix method, and this normally is for covalent substances like carbon dioxide, carbon monoxide, where we'll use the prefix to try to determine the chemical formula. And the last one is the crossover method, okay, where we have talked about using the valency and crossing over like what we've seen over here. Now, maybe just a challenge for everyone. For sulfuric acid, I'd like you to take note. This can also be thought about as hydrogen sulfate. Okay, so can you use the crossover method to get this formula? Nitric acid can also be thought of it as hydrogen nitrate. And lastly, hydrochloric acid can also be thought of as hydrogen chloride. But as you go into the formula, the chapter of acids, you will understand a little bit more, okay, of why are they acids. Okay, but for now, if you want to get the chemical formula of it, you can think of it as hydrogen sulfate, hydrogen nitrate, hydrogen chloride. Try to do the crossover method to try to get these formulas. Okay, so that's all for this video. Thank you very much. Okay, do make sure you become a master of the elements.